Hello everyone, now we'll start with carboxylic acid and their derivatives. We have around 13 questions in our carboxylic acid and derivatives. We'll be covering all the questions in today's video. So question number 1, what is the product of the following synthesis? Multiple reactions we have to perform on butene, and there is a reaction with HBr, with peroxide, magnesium with dry ether, carbon dioxide in the presence of dry ether, H3O plus and SOCl2. So let's see what all will happen. So when we'll do HBr with peroxide, anti-Markovnikov's addition of bromine will take place. So this is the molecule what we will get. Mg and dry ether will form the Grignard reagent. So that is MgBr. Then CO2 may C double bond O. So this is delta plus and this is delta minus. So the attack will be something like this, and it will form C double bond O MgBr. After the treatment with acidified water, what we'll get is MgBr will be replaced by H plus, and we will get along with this MgBrOH. Then if we treat it with SOCl2, so OH will be replaced by chlorine and it will form COCl. So this is your compound D. So answer is D. Now come to question number 2. Which of the following is not an acid anhydride? You have to see which of the following is not acid anhydride. The compounds are given. So if you see question number, so option number A, in option number A we have anhydride. Anhydride is RC double bond O, OC double bond O R group. This particular group is matching with A, also matching with C, also matching with D, but B is the cyclic ether is what is formed, hence B is the right answer. Now come to question number 3. Which is the product of the following reaction? We have been given a compound where we have which all functional groups. First of all, identify there is an acid halide, there is a anhydride. So both type of groups are present over there. Anhydride and acid halide both can be hydrolyzed in the presence of a base. So basic hydrolysis is possible in case of both. If I have RC double bond OCl, then in that case basic hydrolysis, that is base reaction with water addition in the presence of base will happen. This is how it will be. It will form RCO minus and OH and then Cl, where this will SN2TH type reaction will take place and RC double bond OOH will be formed. Plus, because there is a base, that is NaOH, that will replace the hydrogen with Na and will form RCOO-Na. So acid halide will convert into RCOO-Na. Similar thing will happen in case of anhydrides also. I will show you how the anhydride reaction will take place. So if I have an anhydride, that is RC double bond O, OC double bond OR. Exactly same thing will take place. OH minus will attack over here, forming RCO minus, OC double bond OR and OH. Then this oxygen will do SN2TH type reaction and will cause the formation of RC double bond OOH. Now because there is NaOH present, acid-base reaction will take place and RCOO-Na will be formed. Even in this case, RCOO minus is forming, which will ultimately react with NaOH and will form RCOO-Na. So this is how the reaction is. So basically the base hydrolysis will take place in case of both acid halides as well as anhydrides, and the attack will happen in such a way that the carbon oxygen bond will cleave, the C double bond OO bonds will cleave, okay, and you will get ONA over here and H over here. Similarly, ONA over here and H over here. Similarly, ONA over here and, sorry, my bad, not cleaving here, it is displacement, my bad. So here you will get ONA instead of Cl. So ONA is not coming directly, basically OH is forming and then it is further reacting with NaOH to form ONA. So this is your product D. This is your compound D. So option is D. Now come to question number 4. Which of the following is not an acid derivative? Acid derivative ka generic formula is RC double bond O and the functional group. So C double bond O should be attached to a functional group. In case of A, we have RC double bond O and O type of structure, which is an ester. In B, we have RC double bond O Cl, which is an acid halide. In case of C, there is no functional group attached to C double bond O, whereas in case of D, we have RC double bond O, OC double bond OR. So this kind of functional group is present. So all these A, B and D are acid derivatives, but C is not. Now let's talk about question number 5. Which of the following is the strongest acid? So acid becomes stronger when there is an electron withdrawing group. If you talk about the first compound, it is simple benzoic acid, no electron withdrawal, no donation. You talk about the second one, there is C double bond with benzoic acid and chlorine is exhibiting -I, so withdrawing. So second is stronger acid than first. So first is out of picture. Okay. Now come to compound number third. We have Cl, Cl and COOH, -I and -I. Definitely both are withdrawing. Hence, third one is stronger acid than the second one. So second one is again out of the picture. Okay, so far third one is the stronger. Now compare it with fourth. In case of fourth, what all we have? In case of fourth, we have 3 chlorines here, here and here, and COH, all 3 exhibiting -I. Definitely fourth one is stronger than the third one. And come to the fifth one. Fifth one will have so many chlorines, 5 chlorines with -I. Very, very strong acid. So strongest acid is E, because the -I groups are increasing, electron withdrawing groups are increasing on the benzene. Why we are saying -I for chlorine? Because -I is stronger than +M for halogens, especially chlorine, bromine and iodine. Now come to question number 6, which is the major organic product obtained from the following sequence of the reactions. So we have been given carboxylic acid, we have to treat it with SOCl2 and then alcohol, and let's see what we will get. So this reaction, SOCl2 replaces the OH with chlorine, releasing the SO2 gas. So it will form acid halide, and then acid halide will get attacked by an alcohol. The C double bond O carbon has a delta positive carbon, so oxygen will attack like a nucleophile. And after that, it is simple SN2TH type of reaction. Once it will form CH3OH and O minus. O minus will try to get the electron density back, so it will push, and the chlorine is a good leaving group, so it will leave. Good leaving group, it will leave, and from here CH3OH may say H plus will be out because oxygen is carrying a positive charge. So we will ultimately get an ester and HCl will be out, which is our option A. This is our option A. Now come to question number 7. Question number 7 is give the major product of the following reaction. Here we have been given an ester. We are going to reduce it first and then we are going to perform a transesterification step. So the reaction which is involved in the second step is transesterification, where R group gets replaced by the another R group in case of esters. So LiLH4 first of all will be able to reduce your ester, and the reduction will happen in such a way that both the parts C double bond O and OCH3, both parts will become their respective alcohols. So this will become CH2OH and CH3OH. After this, we are going to treat it with an ester again. And ester, when treated with an alcohol, what happens is the transesterification steps takes place. So here we have to see which type of R chain they have reacted with, or what kind of R chain they are expecting in the product. So if you see in all the options A, B, C and D, we can see a cyclohexane. So that means they are reacting it with this alcohol. And in this alcohol, how the reaction is taking place, let's see. So this is my ester which has a delta positive carbon, and alcohol co-oxygen is acting like a nucleophile attacking over there. Once it is attacking, it will form the situation like this, where OCH2 cyclohexane and then H with a plus charge, and something like this will happen. In this, basically you will have this whole reaction is taking place in the presence of an acidic medium. So this O minus will become OH, and here this is how the situation would be. When this H plus will be out, there will be a proton transfer and H plus will go to the ether oxygen. Why? Because it is more electron dense oxygen. It can go to OH also, and it can go to the normal ether oxygen also. It can go back to this oxygen. If it will go back to this oxygen, it will be a reversible reaction. Out of this OH and this ether oxygen, O of etheroxine is more electron dense, hence H plus will go over there. So this is called proton transfer step, and you will get OH plus and this kind of arrangement. Now, when this is what you are getting, this OH plus is what is formed. Now, oxygen will try to break the bond with something. So it will cleave the bond over here. It will cleave this bond, and this lone pair will be given to the carbon at the same time to form the bond with the carbon. So this part, this cleavage, it will cleave this bond, and ultimately forming this as an alcohol. This will give away the H, so H plus is out from this side because oxygen is giving the lone pair to this carbon, and it will form C double bond O, OCH2 and cyclohexane. Now, one thing which I want to tell you is this reaction seems to be very difficult to happen because it is acid catalyzed. Trans-esterification is preferably base catalyzed. Both can happen, but base catalyzed is much better and much faster than the acid catalyzed reaction. They have expected us to do acid catalyzed reaction, but base catalyzed is the one which is more efficient, faster and better. So both ways it can happen, and this is the acid catalyzed mechanism. So this is how we will get the alcohol and the respective ester with a change of an R group. So here it was ethyl group present earlier, now it has CH2 and cyclohexane present. So complete exchange of R group has happened. Now come to question number 8, which is what is the major product of the following reaction? Amide has been given and we are reducing it and then hydrolyzing it in the acidic medium. So CONH2 on reduction always gives you CH2NH2. CH2NH2, when you will hydrolyze in the acidic medium, nothing will happen, only the acidic H will go and get attracted towards the NH2, forming NH3 plus. That's it, nothing else is going to happen. So LiLH4 does the reduction of amide, and it requires water molecule to supply hydrogen on both the sides. But if it is in the acidic medium, in that case the H plus can eventually go to the nitrogen because it is a basic atom and can form H3 plus. So this is your option number B. Now come to question number 9. In question number 9, we have been given amide again and P2O5, which is a dehydrating agent. We have to find out A, then we have to do Grignard, find B, then we have to do I2 with CaOH whole twice and do C. We have to find the products. So here we have been given amide P2O5 is a strong dehydrating agent, and when it will dehydrate, it will take away the water. So H2 and O will be removed and it will become C triple bond, and that is cyanide. Okay, this is something which is an unusual thing which you might be seeing because we have not covered this in the reactions. We'll be covering it in the amide chapter when we'll be talking about the amide as a functional group. Now the C triple bond N can go through the Grignard reagent reaction, simply forming an imine kind of arrangement. Then H3O plus will form. So this, when you'll add water, this will cleave and you will get a ketone plus NH3 plus MgBrOH. This is what you will achieve. After this, the reaction given is with the calcium hydroxide and I2, which is nothing else but a base and I2. And it is again nothing else but the iodoform reaction. Instead of NaOH, we have used CaOH whole twice, but it should not matter at all. So in this case, what will happen is when you do the iodoform for a methyl ketone, what kind of reaction does it takes place? So basically this cleaves from here. It forms CHI3, this is iodoform, and this part forms RCOONA, which is a sodium salt of carboxylic acid. Here it will form the calcium salt of carboxylic acid and CHI3, so iodoform is generated. Now this molecule can further do dry distillation and can convert into, so it is something like this. This is what we have achieved after the reaction. And then when you heat it, CaCO3 will be out. Sorry, I have made the molecule wrong. So this is O, Ca and O. So this is CaCO3 will be out and the ketone will be achieved. So this is the molecule which we'll get. So option number C. Now come to question number 10. Again the amide is given and P4O10 and heat is given, which is clearly a dehydration reaction. Just now we have discussed P2O5 is a dehydrating agent. It will remove the water content from the amide and will convert into a cyanide. Okay, so this is your option number B. Come to question number 11. In question number 11, which of the following reagents would reduce the carboxylic acid and esters into alcohol? So we have been given hydrogen with nickel, which will not be able to. So we need to know which particular. So this is more an information-based reaction, where clearly LiLH4 is the only one which is strong reducing agent and strong enough to reduce carboxylic acid and esters both. So your LiLH4 will be able to reduce your carboxylic also into alcohol and the ester also into respective two alcohols, because it cleaves the molecule from RC double bond OOR dash. Both the groups becomes the respective alcohols. So NaBH4 is a weak, NaNH3 also does not work here, hydrogen nickel also doesn't work, zinc and mercury amalgam also doesn't work for the carboxylic acids as well as esters both. Now question number 12, when the lactone below is treated with LiLH4, what is the major product? It is again an ester. An ester, when treated with the LiLH4, I've told you multiple times, it cleaves this bond as well as this. So alcohols are what we get. So alcohols get formed from both the sides. So your C double bond O also gets converted into its respective alcohol, and this ether wala linkage also becomes alcohol, so it will become CH2OH and OH. And so this is nothing else but acyclic diol, which is your option number E. Now come to question number 13. In question number 13, we have been given an ester of benzene and we have been asked to nitrate it. Nitrating mixture is given. So if you see, nitration can happen only on that benzene where the electron donation is happening, because electron rich benzene we require. So that NO plus, because your NO2 plus HNO3 is going to generate NO2 plus electrophile. So this electrophile has to get attracted towards the electron rich area. If we are talking about this benzene, electron withdrawal is happening from this benzene, so no electron density. If you look at this oxygen, electron donation is happening, plus M is happening, and hence the density will be on ortho, para and ortho. So let's look at the options. In options we have para as a product. We can put a para over here. Para is anyways major, so NO2 plus will go over here on the para position, and this is your option is, which is your option number C. So here we are done with the questions of carboxylic acid and their derivatives. In the next video we'll talk about decarboxylation questions of carboxylic acid from MSC. Thank you.